The probability that a number selected at random from the set of numbers 1, 2, 3, so on 100 is a cube is, here number of sample points, n of s has set of 100 numbers, so n of s equal to 100, and n of a is here the event. The event is the selected number must be a cube. So in A we can write 1 cube, 2 cube, 3 cube, up to 3 cube only. Okay, 4 cube also we can write, because 1 cube is 1, 2 cube 8, 3 cube 27, 4 cube 64. If you take 5 cube it will be 125, but we have only 100 numbers, so these are the cubes from 1 to 100 numbers. So number of elements in set A 1, 2, 3, 4, 1, 2, 3, 4. So n of A equal to 4. Therefore probability that a number selected at random from the set of 100 numbers is n of A by n of s. N of A is 4 and n of s is 100. So 1 by 25. Next question. The probability of choosing randomly a number c from the set of 1, 2, 3, so on 9 such that the quadratic equation x square plus 4x plus c equal to 0 has real roots. So the given quadratic equation x square plus 4x plus c equal to 0. This equation has real roots. This is the given clue for this sum. So real roots means b square minus 4ac. Discriminant must be greater than or equal to 0. Okay, from this a equal to 1, b equal to 4 and c equal to c only, and substitute. B is 4 square 16 minus 4 into 1 into c greater than or equal to 0. 16 minus 4c greater than or equal to, then 4c minus 16 is less than or equal to 0. Multiplying both sides with minus, it changes the sign. So c less than or equal to 4 table you can cancel, c less than or equal to 4. So c values we have to take up to 4. 1, 2, 3, 4, because equal symbol is there. So up to 4 we have to take. So total number we have 1, 2, 3, 4 out of these 9 digits. Therefore probability of A equal to 4 out of 9 digits. 4 by 9 is the answer. Here the options are 1 by 9, 2 by 9, 3 by 9, 4 by 9. So 4 by 9 is the answer. Next one, words with or without meaning are to be formed using all the letters of the word examination. So here the given word is examination. The probability that the letter M appears at the fourth position in any such word. The probability that letter M appears at the fourth position. Here the given word is examination. And this examination word has 11 letters. Totally this contains 11 letters. In these 11 letters there are 2 A's, 2 I's and 2 N's. These are the repeated. And n of A equal to totally n of A, and n of S is actually n of S is total 11 factorial, because there are 11 letters has to be arranged, and out of these are the repeated. So 2 factorial, 2 factorial, 2 factorial is n of S, and n of A, here the condition is M appears at the fourth position. So out of these 11 letters, M is fixed at the fourth position. So the remaining 10 letters can be arranged in 10 factorial by, in these 10 letters there are these are the repetitions again. So 2 factorial, 2 factorial, 2 factorial. Okay, therefore probability of M appears at the fourth position is n of A by n of S, and both denominators get be cancelled. So 10 factorial by 11 factorial. We can expand 11 factorial, the greatest number we can expand, because 11 factorial can be written as 11 into 10 factorial. 10 factorial is cancelled. So 1 by 11 is the answer. Next one, a 5-digit number is formed by the digits 1, 2, 3, 4, 5 with no digit being repeated. The probability that number is divisible by 4. Here the given digits are 1, 2, 3, 4, 5. We are forming the 5-digit number. Take 5 boxes. A number is divisible by 4. If a number is divisible by 4, then the last 2 digits, number formed by the last 2 digits is divisible by 4. So here we can place any number, but the last 2 places must be fixed with the numbers, those who are multiplied divisible by 4 or multiples of 4. So we can write in this way. Okay, 1, 2, 12, 1, 3, 1, 4, 1, 5, like that you can check. And 2, if you take 2 fixed, then 2, 4 is divisible by 24 is divisible by 4. Okay, if you take 3 fixed 3, and 32 is divisible by 4 and 52. So these are the 4 numbers which is divisible by 4, and in the remaining 3 places can be fixed with the 3 numbers. The remaining 3 numbers. Here any 2 digits can be fixed here, 1, 2 or 2, 4 or 3, 2 or 5, 2 in 4 ways. In 4 ways. Okay, these are arranged in 4 ways. Okay, and the remaining 3 places can be filled with the remaining 3 digits in 3 factorial ways. Therefore, total number of ways, multiply these two, total number of ways can be written as n of a. N of a is 4 into 3 factorial, which is equal to 24. 3 factorial is 6. 6 into 4 is 24. And p of a is n of a by n of s. And what is n of s here? We are forming 5-digit numbers. 5-digit numbers can be formed in 5 factorial ways. So this is 24 by 5 factorial. So 24 by 120, which is equal to 1 by 5. 1 by 5 is the answer. An integer is chosen from 2k, set to 2k. Here k is defined like minus 9 less than or equal to k less than or equal to 10. The probability that it is divisible by both 4 and 6. A number is divisible by both 4 and 6 must be multiples of 12. That means it should be divisible by a number 12. It is divisible by 12. Then only the number divisible by 4 and 6 both. Okay, here the given set is equal to, okay, here 2k, k value starts with minus 9. So substitute in the place of k minus 9, minus 8, minus 7 up to 10. So totally there are 20 numbers in this because equal symbol. So minus 9 to 10 there are totally 20 numbers, and all those numbers must be multiplied by 2 because in the set it is given 2k, defined like 2k. So 2 into minus 9, so starts with minus 18, so it is minus 16 and so on up to 20 because 10 into 2 is 20. So these are the 20 numbers totally, okay, because 0 is also there in this, okay, and n of s is totally there are 20 numbers. Okay, and what is a? It must be divisible by the number formed by the numbers are formed by this number is divisible by 4, both 4 and 6. Okay, and that means it is divisible by 12. Okay, and what are the numbers which are multiples of 12 are divisible by 12 in this set, in the set of minus 18 to 20. Okay, in this minus 12, 0 and 12, only we have 3 numbers. These are the multiples of 12. That means these are the numbers divisible by 12. So what is n of s? P of a, probability of a equal to n of a. There are 3 numbers out of 20 numbers. So 3 by 20 is the answer. If A and B are events of a random experiment with P of A equal to 0.5, P of B is 0.4 and P of A intersection B is 0.3, then the probability that neither A nor B occurs. Here P of A is 0.5, P of B 0.4, P of A intersection B is 0.3. Then the probability of neither A nor B occurs. That means P of A bar intersection B bar. Neither A nor B occurs. So P of A bar intersection B bar can be written as P of A union B whole bar. Okay, P of A union B whole bar can be written as 1 minus of P of A union B. And from the union theorem, from the addition theorem on probability, P of A union B is P of A plus P of B minus P of A intersection B, and these three answers are already given in the question. 0.5, this is 0.4, minus intersection is 0.3. Okay, 1 minus 0.9 minus 3, 6. 1 minus 0.6 is 0.4. So 0.4 is the answer.